Hi, this is Nidhi Patel, and the tool that I chose to do my research project on is Clustal Omega, which is a multiple sequence alignment or MSA program. MSA is used to compare a set of sequences in order to study the homology and evolutionary relationships between them. And Clustal Omega is able to do this for thousands of sequences in a matter of hours. Clustal Omega can either be run through a web server or it can be downloaded as a standalone version. This tutorial will be on how to use the web server that's powered through the EBI. So for this example, the data set that I chose to use included species from the Elephantidae family, which I accessed from the NCBI taxonomy browser. 7 of them had complete mitochondrial genomes available, and so that's what I used to conduct my MSA on Clustal Omega. These included Elephas antiquus, or the straight-tusked elephant, the Asiatic elephant, the African savanna elephant, the African forest elephant, the American mastodon, the Columbian mammoth, and the woolly mammoth. For the first step in using Clustal Omega, we have to input our sequence set. So in this case, we're uploading DNA sequences, so we choose DNA. And now we can actually start inputting our sequence set. So for the sake of time and convenience, I've already added them all in here in a separate tab. And I'll just show you how to use this box in the first step by using the very last sequence from this sequence set. So you just copy the FASTA file for each. This includes the header, and then you paste them into the box in step 1, one by one. Now in step 2, you get to view and or edit the parameters. And although I'm keeping the defaults, I'll still go through each one of them. So the output format we are going to keep as is because, in my opinion, this Clustal W with character counts is probably the easiest format in which you can read and understand the results. Then de-align input sequences allows for the de-alignment of the sequence set by removing any existing gaps through the default option of no. Embed-like clustering guide tree uses a sample of the sequence set in order to generate a guide tree much more quickly through the default option of yes. Embed-like clustering iteration uses clustering for each iteration through the default option of yes. The number of combined iterations allows the number of guide tree iterations and HMM iterations for this multiple sequence alignment to be selected from a value of 0, which is the default, to 5. Then both max guide tree iterations and max HMM iterations limit the number of these specific iterations within the combined iterations. So values include -1, which is the default, which turns this parameter off, and then also 1 to 5 based on the selected value for the combined iterations. And lastly, order dictates the order in which the sequence set appears in the final multiple sequence alignment. This can be aligned, which is the default, where the order is determined by the alignment, or input, where the order is preserved based on how it was inputted in step 1. So now you just submit your job and wait for the program to finish running. As this can usually take a while, and I'm still working on using the screen recording app more comfortably, I'll continue this video with the results of this multiple sequence alignment in the final tutorial. Thank you.